Bismillah ar-Rahman ar-Rahim, ICT IGCSE theory revision presentation, and today we are going to revise chapter 7, the system life cycle. To go through a system and to design a system from scratch, how many steps we need? 6 steps. Analysis, the first step you have, design, development and testing, implementation, documentation and evaluation. Good. Next, analysis, which is the first steps. Why we do the analysis? In other words, research in our current system. Yes, to research how the current system works, either if the current system is a digital based system or a paper based, meaning the company works on papers. Everything is done through papers. So you need to analyze or research how they input the information into their current system, how they process the information, and how they output the information. Why you do that? So that you see their current system problems or limitations. They might have some kind of limitations or problem that they would like you to fix it by improving the current system or by creating a new system from scratch. Yes? So hence, by analyzing and researching their current system, you can get to the, let's say, the results of what they need to be done to their systems, and what are the requirements and the specifications of the new system that you are going to provide for them. How to do that? How to research the current system? You have 4 methods. You can use one of them or you can use all of them. The simplest one is to observe how they process in their current system. For example, you go there, you sit with the staff and you see how the staff works in the system, how the staff carry the daily routines of doing the system. That's why the name comes observation. Advantage, you can obtain very reliable informations. Why? Because you are actually seeing them doing the processing of the system. Yes, so you will not get any kind of biased informations. Disadvantage is that some of the employee might not be comfortable when they are observed. For example, if you follow them around and see how they interact with the system, they might not like it. Interview, and we say that interview is by grouping the people, sitting with the staff and discussing the new system with them to see what they think about the current system, what they need to be improved, how you can improve it. All these kind of informations can be done through the interview. Advantage, you can ask many questions and you can modify questions. You can discuss with them since you are sitting face to face with them. Disadvantage, is very time consuming. Why? You cannot meet all the staff at the same time. Sometimes they are working, sometimes you need to schedule different appointments at the same time. So it's very waste of time. And you might not get what we call it anonymous views of the current system. For example, the staff might be sitting with the boss and they cannot attack the current system in front of their boss. So they might feel agitated, they might be very conservative in terms of displaying their opinions. The third method, which is easy, which is the questionnaire. You put all the questions that you need and then you distribute it to the audience. And then they give you back the paper. Fast method, you can get very larger audiences. However, the disadvantage is that they might not even complete it or return it back to you. They might not take it seriously. And you cannot expand on questions. Normally the questionnaires, the answers will be true, false, and this kind, yes, taking multiple choice. The last method that you can use is collecting document. For example, you go to the company and you ask the company for the documentation of the current system, the manuals of the current system, and you look at the manual paper by paper to understand how the system works and how to fix it. Advantage, you look at it paper by paper and you get very critical information and accurate information about the current system. Disadvantages, it can be time consuming. You have to look at the manual paper by paper, page by page. As a conclusion of this first step into the system life cycle, which is the analysis, you can use one of them to research the current system, you can use 2 of them, or you can use all of them. Depends on the scenarios, and you have really to weigh between the advantage of the method that you are going to use and the disadvantage of the method that you are going to use. Observations, questionnaires, these are, let's say, does not take time. These are cheaper methods. Interview and document collecting will take more time for the company, and for you will be very expensive in terms of time and in terms of cost. Example from past papers, this question: when a new system is being developed, analysis takes place when method of research in the current system is interviewing. List 3 other methods, and we mentioned we have 4 methods: interview, questionnaire, observation, and documentation. Yes, we're checking the current system documentation. Number B, describe 2 drawbacks of using interview, and if you look, they mention you need to mention the drawback and you need to describe it to get the 4 marks. Yes, the drawback of interview, first of all, is time consuming. You need to sit there and sometimes talk for hours. Yes, this is very time consuming for you and for the employee, because they are leaving their job to sit with you and discuss with you the current system and the improvement that they need to be done. The second disadvantage is that you might not find all of them available at the same time. So you might need to group them in different groups and assign different times or different appointment times for them. You can add another drawbacks, which is if the employees are all sitting together, they might not be able to discuss their opinion in, let's say, a personal way, because whenever they say their opinion, the opinions might attack other employees. In fact, they might be very conservative in terms of giving you the real opinion or the real feedback on the current system. Next stage, which is the design. After you research the current system using one of the 4 methods or all of the 4 methods, then you need to bring a paper and design your system, and you start designing the system from the scratch. For example, in this slide, as you can see, we are designing a system for a bookshop. To design a system for a bookshop, first of all, you need to sit down and look at the system. How many tables do I need? For example, if you are creating a database for them, I need a table for the books. Yes, I need a table for the authors. I need a table for the membership of the bookshop, and I need to link them together to insert the data in front of them. So you need to put down this kind of information. The first thing you need to design is, as we mentioned, the tables. How many tables you need in the system, and not only the tables, you need even to indicate how many fields inside each and every table and the data type that you need inside that table, just like you do in Microsoft Access in the database. Whenever you are importing the table, you should know the field names and you should know the data type, which is a way of validation. Yes, and then to insert information inside the table, you need to prepare forms or data entry forms. Why we need the data entry forms? To import information or new records inside the tables. And the form should look attractive, should look professional. And to make a form attractive and professional, there are features that you need to follow. For example, are written here. Appropriate spacing between the field that you can see here. Yes, very small empty space, easy to read font and size. The background color should always meet the logo or the house style of the company itself. Drop down menus just like in the genre here to make it faster for the user to fill. Tick boxes or option groups like you see here in the size to make it easier for the staff to select that records. Plus other features such as navigations and buttons that can help the user do different operations. By adding all these features or some of these features, you are making your form more attractive and easier to be used by the staff of the bookstore. Yes, so now what we designed, we put on paper how many tables we have and even the specific field inside each and every table for the system, and we design even the data entry forms, and we make sure that we use some of the features of the forms. What else we need? We need to design what we call it data validations, and by validations, some kind of criteria to minimize the number of mistakes that can happen through the system by the user. Yes, meaning if you would like to define data validations, it must fulfill specific criteria to ensure that data is valid. Yes, different validation technique can be used in different fields. For example, these are the ones that we need to know in the IG. We have a validation called presence check, range check, length check, type check, and format check. Yes, these validation to minimize the error. Let's have an example of them. For example, if we have this database here and we have this full table, we might need first to use this validation and presence check. The presence check validation is to make sure that this field is always filled with something, is not left blank. The field should not be left blank. Let me first clear all the validation that I've done before, just to make sure that we start from scratch. Yes, now we are good to go. For example, to do the presence check, let's make sure that the field first name should not be left blank. For example, if I delete this name and try to move on, the system should prevent me from moving on. The system should give me a warning. This field should not be left blank, isn't it? How to do it? I need it for the first name. You go to the design view, you go to the first name, you have the field properties down there, as you can see, and in the field properties you have validation rule and the warning message, which we call it validation text. What the rule should be? Should not be left blank, not null, meaning it's not empty. If the user left it empty by mistake, what message should appear? Error must contain something. You get it? Now we have set the rules and we have set the warning message. Let's save it, go back and test it. For example, if I remove again the first name and try to move on to the club, immediately the system will warn me and remind me that this field is empty. It should not be empty, it should contain something. This is which one? This is the presence check, one of the validation techniques, and as we mentioned, validation are there to minimize the mistakes and make sure that all the data inserted are within an accepted range or criteria. Can we do the range check as well? As you can see, the range check is making sure, for example, if the field accept a specific range. Let's do it. Let's go, for example, for the age field. If I look at this field accept numbers between 0 and 100. Simple. So if I put here 200, it will still accept it. Any number will accept it. Now I need now to put a specific range where the field should accept only numbers from 0 to 100. The field name is age, January. I'll go find the age, January. Again, go where? Validation rule. What should be written there? I need to accept between 0 and 100. So I would say between 0 and 100. Simple. What should be the message? If the user inserted anything below the 0 or above the 100, the message will be error, if I can spell it correctly, only numbers between 0 and 100 are accepted. Simple. And then let's test it and see whether this specific validation works. Let's go here and change this 59 into 200 and try and move on. Immediately the system will restrict you from inserting any number, as I said, above or below the range, and that's why we call it here, if they ask in the exam, a range validation check, where to make sure that the system or a specific field or a specific table accept a certain data. Are we good? Let's move on. Next, a length check. Now this is just like what happens whenever you are registering for a username and password. If you notice, most of the website, they have limitation on the password. You can't just put 2 numbers or 3 numbers as the password. They will ask you to put at least 8 to 15 numbers or 8 to 15 letters. You get the point. The password should not be too short and should not be too long. Just like what's happening here. You can actually restrict the system, a specific field, so that it can have a specific length. Yes, and we call it length check. For example, if I go to these codes, the entry ID, if you look at them, all of them, they have the same length. 1, 2, 3, 4, 5, 6. All of them are 6. So let's restrict it so that I cannot add extra numbers. The code should always be 6. I will go to the field as usual, and again I will go down there in the validation rule, and I would say quotation, I need to reserve 6 positions, and the positions will be done by question marks. So double quotations, and then 1, 2, 3, 4, 5, 6 double quotation. Yes, 6 question marks between double quotation. The question mark means any letter, any symbol can be inserted. However, the maximum numbers are 6. Yes, and the message will be max is 6 letters. Let's say error max is 6 letters. This will be your warning message. Let's test it. So if I add any numbers and try to move on, I get the error message. And this is what we call the length check. The type check and the format check, normally these are very important, and the simplest one, most of the time they are done by the system. For example, the type check is, for example, making sure that a specific field is numeric or text. And this is done by the system when we import the tables. For example, if I open these tables, whenever you are importing a specific table, you set different type check. For example, you say that this is a number, should only accept numbers. This is a date and time, it will only accept date and time. If you try to insert any other information in this specific field, it will not be accepted. The license is yes, no, or Boolean. It will never accept anything but yes and no. So this one is done normally whenever you are creating a table or you are actually inserting a table into your system. The same for the format check. To have a specific format, for example, for the date, to have 2D, 2 M's, and 4 Y's, let's say. For example, if I go here, I have a date and time field, which is the race time. I can actually set a specific format for it. Yes? For example, I can set this medium date format. By this, I'm actually putting a validation rule. All the dates should follow this format. If you try and put any different format, the system will automatically reject it. Very good. So these are options, and these are some of the validation rules that you might need again to design on papers. We are doing this on papers. Yes. So everything that we have done now in the second stage, which is the design stage, we do it on the papers. On the papers, you put down how many tables you need. You put down, let's say, a structure of the tables, the field inside the tables, you write them down. On the papers, you write down how many forms you need to insert information into the tables, and of course the number of forms most of the time will be equal to the number of tables. And you make sure that you put some kind of notes like the form should follow a following standards to make it more attractive. On the papers, you will put down the name of the validation technique that you are going to use it and where exactly. Yes? After you do that, you can move on to the next stage, which is the development stage. Meaning, after you make sure that everything is documented on paper, you know your plan, you know your map, you know the steps, you can now move on and open your application, such as Access application, and start creating tables or importing tables or using the application to design your system. Hence, the development and testing stage, the difference between developments and the design is that developments is now you are doing it on the system, on the computer. Whatever you put on paper, now you are projecting it where? Inside the computer. So you start developing using an application such as Access. You start creating the file structures, the tables. You start creating the field names. You start specifying the data type that you can see. After that, you go and you do the validation techniques inside the tables, and you have the reference, you have the papers in the design stage. You know what field you need the validation for, what field should be left without validation. As you can see here, an example of a field that will accept numbers only greater than 0 and less than 26. And then you start even designing the form, the data entry form, so that people and the staff can insert new records inside the tables. Are we good? So developments is doing everything using the package or the applications or the computer. And developments is always linked with testing. Why? After you develop, you need to make sure that whatever you are doing in the computer is working fine. For example, if you insert a table and we just put down that tables are module 1, yes, after we insert all our tables, we must open the tables, look at the tables, try and insert record in the table to make sure that we have done everything correctly, we have set enough field names, and the data types are, let's say, appropriate for each and every field. So you need to test it first and make sure that all the tables are good. And then you need to test the validation technique. Whenever you put a validation, just like we have done a couple of minutes ago, you need to go inside the data and test the validation to make sure that the validation works as it should. You need to test the forms. Let's say if you are inserting some kind of forms, insert a record in the form, save it, go back to the table and see whether the record has been inserted in the respective table or not. If yes, that means the forms are linked with the correct and accurate tables. So after you test all the modules, now you are testing the full program. After you make sure your full program works fine, then you can go to the next step and implement it or give it to the company and ask them now to start using your system. Yes? Testing sometimes might lead to some modification. For example, while you are testing, you might change your mind about some kind of file structure or data. You might remember that you need to add something or delete something. You might add or delete validation rule or even modify some validation rule that you have set. You might use different input method and output method. So always whenever you are testing, you get an idea. Whenever you are testing, you might expose some kind of flaws and limitation in your system that you can fix. Anyway, after you finish development and testing, you move to the next stage, which will be the implementations or implementing the system now inside the company. But before we go to the implementation, let's look at some of the questions that might come. One of the stages in the system analysis and design is called development and testing. Describe the different testing strategies that can be used on a new system. What would you test on a new system? Yes? The testing strategies that you can have are different. For example, you must test module by module. Yes? You must test, for example, the tables. You must test the validations techniques. You must test insertion of data, inputting of data, output of data into the system. All these are different testing environments. Other testing environments is that sometimes you might give some kind of specific data for testing. For example, if we are testing a range validation, the system should accept data, let's say between 0 and 100, and this slide, you might use 3 different types of data to test it. And the types of data are called normal, abnormal, and extreme. If you have a validation that accepts numbers between 0 and 100 only, then you can insert a normal data. Anything between 0 and 100 should be accepted. So if I insert 10, the system should accept it. If I insert 20, the system should accept it. Any number between the 0 and 100, the system should accept it according to my validation rule. These kind of data, I call them normal. Data within a given range, data between the 0 and the 100. And then I can even test it with extreme data, data on the boundaries. For example, I can put 0 and it should also be accepted, and 100, but these are the boundaries, the minimum number that can be accepted with the system, which is 0, and the maximum number that can be accepted with the system, which is 100. Anything above 100 or below 0 will be rejected. That's why I call them extreme. They are sitting where? On the boundaries of the system. And then you can even test it using abnormal data. And from the name, abnormal data means any data less than 0 or greater than 100, and it should be rejected by the system. Yes? From this, we know that the testing strategies is to input data such as normal data, abnormal data, and extreme data inside the system to make sure that the validation works. After you make sure that everything done, you can actually now use live data, which is actual data that would be entered. Yes? For example, the previous system data, you might take the previous system data and insert it in your new system and make sure that it works fine. So answering this question is always by investigating different methods to use it. Next, a new system has to be tested before it can be implemented. A variety of test data is used. Name the following type of test data. Data that's outside the boundaries, we mentioned this, what we call abnormal. Data should not be accepted outside. Data that is on the boundaries, extreme. They are on the boundaries, the minimum and the maximum, let's say, number that can be inserted. Data is not on the boundaries, but it's within the accepted range, and normal data. Yes, can be accepted by the system. Data that has been used before and has known outcomes, live or real data. Next, validation is a way of checking data in a database. Name the most appropriate validation check that match each description below. Make sure that the data entered into field is exactly 10 characters. I'm specifying the length, meaning this is a length validation. Making sure the number is between 0 and 100, range validation. You are setting the minimum and maximum numbers. Make sure the data entered is numeric, a type validation. The type of the field is numeric, the type of the field is text, the file of the field is Boolean, you get the point. Make sure that the data inserted is a specific format, DDMM, and then the years. This is a format check, and normally it's done for the date and time format. Very good. Next, there are different ways to check the data that you have entered into a computer system. One way is verification. And if you notice, we described and defined validation, and we mentioned the validation such as the range validation, the length validation, the data validations. All those are to make sure that the data inserted in the system is within an accepted criteria or within an accepted range. Now, another method of checking the data, we call it verification, and normally verification is different. We have two methods of verification: visual verification and double data entry verification. The visual verification meaning if I ask you now to open a table and insert a record from the past paper question paper. Insert a specific record into the table. After you insert the record into the table, you need to make sure that the spelling mistakes are not present, that everything has been inserted accurately. You double check again with the question paper. You look at the question paper and you look at the information that you have inserted inside the computer. This is what we call it a visual verification. You always double check with the original source of data. The other one, we call it the double data entry, and you insert the information inside the computer twice, just like what happens whenever you are setting your password in a system. They ask you to insert a password, they ask you to confirm the password. Hence, you insert the password how many times in the system? Twice, and the system will compare them, compare the double entry that you have made. If they match, that means you know what you are doing. If they are not matched, they will ask you to redo them again, and this one, what we call it, double data entry. So the information will be inserted inside the system twice by the same person or by different persons, and then the system should compare them and they should match. This is what we call verification, visual and double data entry verification. Proofreading is something different, just like in Microsoft Word. After you finish, before you print, they ask you to proofread, and proofread is normally comparing it with a dictionary, making sure that everything that you have typed follows the dictionary, fixing the spelling for you. That's why here it says that it's sometimes thought to be verification. Explain differences between verification and proofreading. The difference is verification, I'm comparing with a source. Verification, I'm comparing with an original source. I'm copying from one place to another place, and I make sure that I've copied everything correctly. Proofreading, I'm comparing with the dictionary. I'm looking at the spelling of each and every thing that I've typed. So the difference is proofreading, check with the dictionary. Yes, verification, checking with the original source of the data. Next, is it verification, validation, or neither verification or validation? Data is entered by two different operators. Verification. Yes, data can be, and this is what we call it a double data entry verification. Data is checked to see if it's present. Validation, presence check. Data is checked to make sure it's correct. Which one? Neither verification or validation. Yes. Data entered is checked to see if it matches data on the source document. Again, verification, visual verification. You get the point. Yes. Next, tick whether each of the following is a method of validation or verification. A computer comparing two versions of the data. Two versions are being compared. Verification. Using check digits. Using a check digits to make sure the data has been inserted. This is what we call it verification. Applying a length check. Validation. Performing a range check. Validation. Typing in data twice. Verification. Yes. And visually comparing data on screen with the original data source is verification. Visual verifications. Are we good? Next, the next stage after you have, let's say, developed the system and tested the system and even testing it with the verification and validation techniques we have said, then you move on to implementing the system. How the company will implement or install your system. We have 4 methods: direct, parallel, phased, pilot. Yes, these are the 4 methods. The simplest one and the most dangerous one is the direct changeover. You go to the company, you said, delete your old system, use my new system. So automatically the old system will be stopped and will be replaced by the new system. Advantages: now everything in the system will be tested and the cost will be reduced. Yes, since nothing will be duplicated. The staff will be working on how many systems? Only the new system. The disadvantage is you can never fall back to the old system if something happens to the new system. If you find some glitches or problems in the new system, you can never roll back, yes, or revert back to the old system. And you need to provide quick training for the employees to make sure that they can use the new system. So this one, why we do it normally? Cost less. Cost less. If the company is, let's say, not a very rich company, it's just a small company, they prefer the direct changeover so that they can pay less money. Yes, even though it's very dangerous, and if something happens, you cannot revert back to the old system. And the next one, which is very secure, however very costly, and rich companies, they do it sometimes, which is parallel running. They ask you to implement your new system, and they will mention that you will be using the new and the old system. So both systems will be running at the same time, which give you the advantage of if the new system does not meet your requirement, you can still use the old system, and you can train gradually your staff, yes, doing it in a gradual way. Disadvantage of parallel: duplications, because the staff will be doing or inserting data in how many systems? In 2 systems. Hence will require you to pay more for the staff, and they're using more than 1 system at the same time. Next, phase implementation and pilot implementation, they have the same idea. Yes, both of them, you never implement the system completely, you implement part of the system. In phase implementation, you implement, let's say, the data entry part of the new system, but the reporting and processing will be using the old system. Until you make sure that the data entry of the new system is good, then you move on and you add the processing of the new system, and you leave the reporting only to the old system. Until you trust the processing of data, then you replace the outputting or reporting by the new system. So the new system will be pushed in gradually, step by step, until you make sure that everything is fine. Then you can push further and further until you 100% replace it. Yes, the same idea in pilot running. However, the only differences between these two: in pilot running, you take the system and you implement it in the least important departments. Let's say if you are working in a school, you implement this new system only in the KG departments. Yes, high school and middle school, leave the old system. If something happens to the new system, only the KG department will be affected, and it's the least important department. No communication really is happening there. No real, let's say, education is happening. They are still children. So if something happens there, they can keep fixing it until you make sure the system is good. Then you take it from the KG and you implement it in the rest of the schools. Yes. So the pilot, you put it in the least important department. So if it's not working well, you will not be affected that much. You get it? That's the advantage, and both of them are less expensive in terms of cost than the parallel. Yes, less expensive than implementing it as parallel, meaning the cost is less and the danger is less. You get it? And more expensive, of course, than the direct one. None of the direct one, you are only using the new system. However, it's very dangerous to implement. Are we good so far? Next, below is a list of statements. Each statement is true for only one of the given method implementation. Tick the method which matches the statement. All of the old and new system run at the same time. Parallel. Old and new at the same time. If the system fails in one branch, the rest of the branches will not be affected. Pilot. The new system has to be completely free of error before implementation. Direct. The benefits of the new system are available immediately. Immediately. Direct. Immediately, the benefit of the new system. The whole thing is happening there. Are we good? Next, systems can be implemented in different ways. One of these is direct changeover. Name 3 other methods of implementation. For each method, give an advantage when compared with direct changeover. When compared with direct. Parallel, meaning unlike direct, both systems will run at the same time, and the advantage, if something happens to the new system, you can always fall back to the old system. Phased, unlike direct, the new system will be pushed in the company phase by phase after making sure that each and every phase is 100% working. So if something happens, the company will be affected in only one of the phases of the system, not in the whole system. Pilot, the system will be implemented in the least important department or small departments. So if that department is affected, only that department will be affected, unlike direct where all the company will be affected if the system is down or has problems. Are we good? Next, after system is designed, it will be implemented. For each of the following situations, write down the most appropriate method of implementation. A small company with very little money to spare. Direct. The least expensive one, direct. Remove their old system, put the new system. A company where the most important consideration is not to interrupt production. Parallel. Put your system, but leave our old system. Until we trust your system, then we will remove our old system. A company which only wants a small scale implementation, phased or pilot. Small scale of the system. Next, documentation. After you finish implementing the system, the companies are happy, the users are happy, you must prepare them with some kind of documentation to show them how to use the system. Nowadays we call it the user manual. Yes? And in the user manual, you show them the minimum hardware and software, how to install the system in their computers, how to start and stop the system, example of input and output, yes, exceptional errors, how to fix small issues. These should be distributed to all the staff or the people that working with the system, and we call it the user manual. This is one type of documentation to make sure that each and every one of them will be enlightened and will have some kind of knowledge of how to use your new system. The other big documentation, very important, we call them technical documentation, and these are done for the providers or programmers and for you. You put down each and everything that you have designed in the design stage. The hardware, the data structure that you have put on paper on the design stage, the data type, the field names, the details of the expected input, the details of the validation that you have done, everything that you have done, the flow chart of the system, how the system works from the beginning to the end. All these must be documented so that if you would like to improve the system later on in the future, you will fall back to this documentation to get a fresh review of the system. Otherwise, you will forget. Everyone's forgetting a while. So if the system is running for a couple of years and you would like to come back again to improve it, you will forget how you have done it in the first place. So if you have this kind of technical documentation there, you will be able to remember how everything has been done in the system, and according to the documentation you can improve, fix the errors in the current system. So how many documentations? We have 2 types. User, for the normal user, a technical documentation which for technical peoples to improve and modify the system either now or in the future. Example, the system analysis produce documentation. Give 4 reasons why both user and technical documentation are needed. User documentation needed to explain how the user uses the system. User documentation is to make sure that to tell the user how the user fixes small errors. Technical documentation describes the flow chart of the system if you would like to change it or modify it. Technical flow chart describe details of validation and structures of the system if you would like to alter it by a technicians. You can mention different reasons other than the ones that I mentioned just here. Yes, if you fall back, you can mention any of these points in the users, any of these points, and you will get a correct answers. Next, is it user, technical, or both? System flow chart, how the system works. Technical, how to save a document. This is a user. List of variables. This is technical. The purpose of the system, both of them should know the purpose of the system. Next and not least, the last one but not the least important one, which is the evaluations. And by evaluation is after you finish your system, you need to go back and compare it with the original task and requirements. Yes, whenever you sit with the company, you have specified that you will deliver them with a system that can do such and such and such. After you finish, you implement the system and you document the system. You must make sure that you have met the original task requirements, and you need to identify the limitations and improvements on the system that can be done later if they would like to improve it. And you must get some kind of evaluation from the users in response of using your system, or we call it the customer feedback. Very good. So this final stage, which is to evaluate your new system and make sure that you have really delivered what you promised to deliver. After the evaluation is complete, if there are any problem or limitation with the system, the technicians, yes, according to the technician or user point of view, then the system analyst must refer back to the design stage and fix that problem or limitations. So if you find that anything is missing, you can always go back to the design stage, look at the paper, see where it's missing, add it there, go to the development and testing stage, retest these areas, make sure that it works, and re-implement the system again. Yes, so based on the feedback you get, adjustment could be made or improvement could be made to make sure the system is more efficient and more usable and friendly to the company. Very good. Example, tick whether the following tasks are carried out in evaluation or analysis. Identifying users and information requirements. This is identifying the users and information requirements. Analysis, requirements meaning analysis. Comparing the new system with the original task. Comparing the new system, you are evaluating now, you have finished your system and you are comparing. Carry out research on the current system. Analysis, identifying any limitation of the new system. Evaluation. Yes, a company is going to replace the existing system with a new one. Put the following steps into the correct order that the system analysis would follow. The first stage is always collect information about the existing system. The second stage is design a file structure. The third stage is develop and test the system. The fourth stage will be implementing the system, and the last stage will be evaluating the system. Are we good? So the same steps for the cycles mentioned here. A car company has decided to develop an expert system to help machines within their diagnosis of car. Describe step required in the analysis and design of such a system. Of course, the steps are researching, because you are actually doing some kind of development for the machine for an expert system. So you would kind of research first of all the informations you need, put down all the requirements and designing the tables, the informations, get the information from the experts, yes, or the mechanic experts, and call it the knowledge base. And based of some kind of rules, you will design a user interface so that the information can be extracted from the knowledge base, and then the results will be done for you. Very good. And this is the last slide, which is system analysis, design, development and testing, implementation, documentations and evaluations. with a very brief descriptions of each and every stage. Why we need the analysis? To collect information about the present system. The design is identifying the problems and putting down the requirements and design some papers for the new system. Development and testing, you start now developing using one of the computer application. Implementation, now you start replacing the old system with a new one. Documentation, you create the technical documentation for a later improvement of the system, and the user documentations or the user manual to make sure that the staff knows how to use the system. Evaluations and making sure whether your new system meets the requirements. If you have some problems, either you know them as a technician or as a feedback from the user, you will always revert back to the design stage, fix your design, do again the development and testing, do again the documentation, do again the implementation and documentation, and again do the evaluation until you get zero feedback, zero negative feedback. Then your system is done. Okay, and I think this is the end of this chapter. Thank you very much for listening.